So last time when we were in here, we did another one of the parallel shafts question, right? And I know yesterday I said we were going to do differentials, but I couldn't find many good examples of a differential. I think I have one in the homework right now, so I'm going to take that question out, and I'm going to add another question in there. So the number 2 is a differential. I'm going to take it out and add a new one that is not a differential. So, and we also just don't have the time that we usually do, right? Because tomorrow is the last day of the class before the exam. So I'll just take it out, and you guys can do another one like the ones we've been doing. But I'm going to take us a step further though. So the third step is differentials, right? This one right here is non-parallel shafts. So this is, remember how I told you there's like cases for this chapter? There's like case 1, which is parallel shafts. And by the way, differentials have some of these things right here as well, right? You know, like, but the point is that we're gonna focus on non-parallel shafts because differentials are, well, different, I guess. They're a little more complicated when it comes to solving these. So we're going to learn non-parallel shafts, and then differentials will be something that we will probably not cover. So, but right here, as you guys can see, we have a question at the top left here. Is basically the same question as the one we've seen before, right? But when we get to C, we go to the arm, and then what happens? Well, what happens is that we have a gear system that is connecting a parallel shaft with A, but then it's also rotating F. So essentially we're translating motion from a looking straight into it like clockwise or counterclockwise motion, and then we're translating that to rotating motion down. So essentially X motion to Y motion now, right? Although it's not exactly that, but you know what I'm saying, right? Essentially if you're looking at it this way, X is left to right, that is the shaft that we are starting at the front, or starting with, and then the final shaft is spinning up and, it's not spinning up and down, but the shaft is in the up and down direction. So we're taking motion from in the X plane and moving it to the Y plane, right? And this sort of setup exists in your car. Jackson, what's the name of it? I always get this one mixed up with another one. It's one of the shafts, but it's not. I had to look it up. It's been a rough day already. If you're here, it's not the crankshaft, is it? Or cam? It's one of those two, right? Is it the camshaft? Yeah, okay, it's the camshaft. Yeah. But anyway, that's actually a part of this class, camshaft analysis, but we can't do it because we don't have the computers right now, because obviously we are all at home. And it's actually kind of hard. It's not hard to do, but you have to have a computer software. So that was actually, you would, whenever you plugged in a bunch of the equations that you found by hand, it would show you a cam profile, so how it moves. It's pretty neat. But anyway, so let me go ahead and start up here. So the first thing that we do, as usual, is we write the steps, right? Steps to solving gear analysis. Right? So the steps to solving this, right? So, steps to solving, what was the first step? Analyze the gear train, right? That was the first step. So know how everyone is contacting, what type of motion it has, etc., right? Number 2 was to draw the table, right? The gear analysis table. But for this one, it's a bit different. And so we are going to, we'll talk about that in a second, but it's not too different. The third one was to start writing equations for velocity, right? Start with the input and work from there. right? So start with your input and work from there. So for this question, the input is A, and then it goes all the way out here. So our input is rotating in the, it's rotating in this direction, essentially a torque in like this way. The output is rotating this way. All right, and it says, then the last one was find an equation for, I know I'm just gonna copy and paste that word, so this isn't such a big pain, but for W arm, and plug it into the equation for the output, or whatever one you're looking for, right? It can be anything. It could be the output, it could be one of the other gears. It doesn't really matter, but whatever you're trying to find, right? Because remember, analysis is everything. I mean, if you want to find the output, you can do that. If you're curious about one other gear and how fast it's moving to size it, you can do that one as well. You know, but it just depends on what you're looking for. And then the last one is, this is something we will do today, find the kinematic code for the gear in question. So what that means is that, you know, that H's and all that stuff we've been working on for a while, essentially you have to find that, but for the gears. And it's really easy. I mentioned it yesterday right at the very end. It's really easy. And it's for whatever gear they're asking for. So it could be gear E, gear C, whatever, right? And so that is the steps. So let me go ahead and make that a little bit different so we can have some more room. Okay, so there we go. There's the steps. So we're going to start with step 1. So step 1, analyze the gear train. And so what we have here, I'll go ahead and put a check there. So what we have here is that we have the same setup we did yesterday, right? And that setup is we have a shaft moving gear A. It is externally contacting with gear B. Gear B is on the same shaft as gear C. Gear C and D are internally contacting each other. And then gear C is attached to the arm. And then the arm is attached to gear E and gear F. Okay? So, this is how this one works though. So for doing questions like this, it's better to split these into two separate entities, right? So for example, you're trying to find how A influences F, right? How the input influences the output. So it would make sense to set this up in a way that where you go, all right, well, I'm going to find how A influences E, right? Because that's pretty straightforward, right? If you know how A, if you get the velocity of A in terms of E, then you could also get, since you know E is attached with F, that means that you could find an equation with E in terms of F, and then you can substitute it in to where you would have now one of the input equation in terms of F, right? Do you guys see how that could work? Essentially, since these are contacting, you can get E in terms of F, or F in terms of E, I think, whichever way we're going to end up doing it. I can't remember. But you get one set, these two, in terms of something that we can plug in and get it in terms of A. So really quick, I know that's confusing and long-winded, but the way that you do this is that we're going to draw a line. And what I mean by that is you're not actually going to draw a line, but essentially a line goes down the middle. And what that does is that what that's doing is that we are splitting this up into two mechanisms, or two gear trains. But gear E is still in the first one. So you're going to do A through E, and then you're going to do E through F. And then once you have equations for both of those, you can link them together, right? And so that is the point. So we know how everything is contacting, right? That's our first agenda. Now we have to draw the table. So give me a second to draw the table. It does take a minute. Alright. This one has 1, 2, 3, 4, 5, 6. So it needs 7 columns, I do believe, for the first one. Oh no, we don't have to include that, do we? So 1, 2, 3, 4, 5, 6. Okay, it only has 6 then. Alright, so let me go ahead and do that. So straight up and down. I feel like this is going to be really small. Let me go ahead and increase the size. That's 3, 4, and then 5, 6. It's not that bad. That's pretty good. And then you do the same thing you did before, right? The same conditions. You have arm fixed, gears, locks, and resultant, but you need one at the very top. So to say the gears. So okay. Should be good here. Now I'm going to start filling in the text. Alright, so we have gears. E. Alright, yeah, that looks good. Okay. So gears A, B, C. Oh, I don't know what happened there, but sure. Whatever. Alright, and gear E. Alright, and then we have to do the other ones going down, which are gears locked. Gears locked. Or no, it's not gears locked. It's arm locked. That's the first one. Arm locked. Apologies. And then the second one is gears locked. And then the last one is resultant. Alright, cool. So, we got all of that, right? Now we have to start with the second step, which, let me go ahead and put our check mark down here. So we have drawn the table. Now it says start writing equations for velocity. Start with the input and work from there. So our input is gear A, right? Pretty straightforward. So, with the arm fixed, right? So this is very similar to how the other ones have worked. Let me go ahead and write these equations up here in the top. That might help us a little bit. So equations, we have W arm is equal to W A minus W AR. So W arm is equal to WA minus WAR. So remember, that is that beginning equation, right? And so, with the arm locked, if you recall, because the arm is locked in the first one, this goes to 0. You move this to the other side. WA is equal to WAR. So that is our first one. So I'm going to go ahead and, That is tiny. W AR. I might make that actually a little bigger because that's really hard to say. AR. Whatever. So WAR is our first one, right? Does everybody see how that worked out? Essentially, because the arm is locked, this goes to 0, and then this becomes WA is equal to WAR. And so WA, you plug in where WAR is. And now we have to look at our next gear set. So our next gear is A and B contacting each other, right? So, and it's externally contacting, which means that, let me write the other equation over here, so this one works out for us. Remember this, it is N, so I'm going to write this NA times WA is equal to NB times WB, right? And so this is like the setup equation, right, for how all of these things contact together. So remember, this is the setup equation. So essentially, gear teeth times the velocity is equal to gear teeth times the velocity, right? So using this equation, right, obviously there's a plus or minus in front of this. I forgot to add that. And there's a plus or minus because it depends on the contact. So if it's externally contacting, which in this situation it is, there is a minus sign in front of this. So you would put a minus sign. Internally contacting, you leave as positive. But let me go ahead and start writing the next one. So for this part, we have omega b, so WB is equal to NA over NB, the opposite of NA over NB. Times omega AR. Do you guys mind if I leave it like that instead of changing the font? I feel like the font thing is kind of gonna be a nuisance. So I'm gonna leave it like that. But just know that whenever I say like WAR, I'm not saying times war, I'm saying times WAR, right? The relative velocity of A with respect to the arm. Okay. Anyway, so we got that. So now we have to move to the second one, or the gear C. So gear C's velocity can be done by just taking, it's the same velocity as gear B because they're attached on a shaft here, right? And so since they're attached on a shaft, it means gear B and C have the exact same velocity. So, and you write it as the exact same. You would do NA over NB times that, and put a negative sign in front. All right. Is everybody with me so far? All right. Cool. So then we move on to gear D. So recall, gear D is externally or internally contacting with gear C. So we use this exact same format, right? But only there is a positive sign in front, not a negative. So we have to use the same format again, except that you replace it with C's and D's. So you would go NC WC is equal to ND WD, right? And you replace it, and since we would already know a relationship, we already know the equation for WC, you take this and plug it in there, right? So, if anyone needs me to do that, I will do it. But essentially, I'm going to try and do it myself, which really, I think it's NC over ND. Stop me if you think I've made a mistake. I probably will here. And then this one would be NA NB times WAR, right? Yeah. So does everybody see what I did there? Essentially, I plugged in W, so you did WC here. WD is equal to WC times NC. You move the ND to the other side. And then you plug in the equation for WC into where WC is, and then you get this total equation. I can write it out, I guess. It'd probably be more helpful. So NC times WC is equal to ND WD. And so we're trying to find an equation for WD. So if you take ND and move it over here, that's how we got the NC over ND. And then WC is equal to this setup right here. So that's how I got the NA over NB times WAR. Right? Hopefully everybody's good with that. Alright, so I'm gonna move on. So now the next one. So if the arm is fixed really fast, so if let's say the arm is not moving here, what does that mean for gear E? Since gear E is on the same shaft, right? As the arm. What does that mean for us, for gear E? Remember, velocity equals velocity. One velocity equals the next if they're on the same shaft. So if the velocity of the arm is 0, is it though? What do you mean same with C? Do you mean that it is since it's on the same arm? Since E is attached to the arm and the arm is not moving, are you saying that it's 0 because they're on the same shaft? Are you saying it's the same condition as C? Because that's right, it is the same condition. Yeah. So it is 0. And the reason why, guys, is like I said, the arm is locked. And the arm is this piece right here. And if this piece is not moving, obviously gear E is not moving either because it's on the same shaft, right? It's just sitting there. So gear E has a velocity of 0 in this case. Alright. Now we have to do gears locked. I bet you this one's everyone's favorite because pretty straightforward, right? You just plug in if the gears are locked, therefore everything else is just it's the speed of the arm though. But so really fast. We have replaced, if anyone didn't notice, the reason why we don't have the arm here is because we replaced it with E. Because E is the same as the arm in terms of velocities, right? And that's what we really care about. We're caring about velocity right now. E is the exact same as the arm in terms of velocity because they're on the same shaft, right? That would be like if we, so think about it this way. That'd be like if we skipped B because we know it's the same as C. But only this, it makes more sense to show B, I guess. But the point is that since the arm is the same as E, we skipped it and just put E there. Because if we know E, we know the arm, right? And so you can do the same thing with the velocity. So the velocity of the arm is equal to the velocity of gear E, right? Would you guys agree with that? Since they are connected to the same shaft, right? They have to be the same. So therefore, what we should write here is WE. Although I am going to change that because that makes it look like we. Alright. Yeah. I lost one. So now we have the same setup as the last one, right? We have the resultant here is, which like I said, is that all of that equals these. So what I'm going to do is I'm just going to add these together so you guys can know how the equations look. So, but I'm going to put it in terms, I'm not going to change the font size, so do keep up WE. So WAR plus WE equals WA, right? So I'm writing all, but remember all of this column right here is equal to the velocity at the top. I'm just showing you what these two together are added to be. And then the same thing, I should have just copied it over, didn't think about it. C, D, oh, I forgot. Yeah, okay, I forgot. I've been doing it wrong for just a second. I have to turn down the plus WE. I forgot to do the same thing with this one too. So both of these have the exact same thing as well. Yeah, I forgot to add this part. So it was this plus this, right? My mistake. Let's turn it down a little bit. There we go. So like I said, you take this, you add this, and this is what you get, right? I hope everybody is on that page. And then 0 plus WE equals WE, right? So this one is pretty straightforward. WE is equal to WE. All right. So this is our table. Once again, I said if you get here, I will be very happy with you. Because that's like the main part of this, is just being able to do this part. So we have done step 3. Step 3 has been solved. Now we have to find an equation for the arm. But in this case, it's WE, right? Because we've already made that substitution. So we have to find an equation for WE in this case. The arm and E are the same. So, how do we do that? Well, if you guys remember from yesterday, this question is basically it's the exact same as the one yesterday. And so what do we use? We use the fact that one gear D, is fixed, right? It has like it's grounded, I guess I would say. So because it is grounded, that means what? That means that we're going to take this column, gear D, so this one right here, and I'm going to write the full equation out over here. So really quickly, it is WD is equal to 0, because remember it's grounded, it's the grounded condition. WD is equal to 0, which is then equal to minus NC in B, what is it, ND? Yeah, ND. Then it's ND NA times WAR plus WE. Right? Make sure that's correct. NC over ND, NA over times that. Okay, cool. And so that is the equation. If you take this, add it with this, you get that. And then because WD is equal to 0, we have an equation set equal to 0. And what that means is that we can find an equation for the arm here. Because WE in this case is the arm, right? And so we can continue with this relationship and we can move it down, right? And we can replace. So remember, we have to replace WAR because we do not want relative velocity in this term. We want things that we know, right? And so if we do things that we know, we'll end up with minus NC and D and A and B times the quantity. This would be W2, or WA, sorry. WA minus WE, right? Because remember, WE is the same as the arm here. So we can replace that, just like we've done in all the other ones, except that WE here is we're taking the place of the arm, right? Because the goal of this, guys, if you remember, is we have to get A in terms of E. And then once we have A in terms of E, we can then do the same gear, analysis that we did with this table, and we can do it with E to F. And once we know E in terms of A, or A in terms of E, we can then plug in that equation into this one, the one between F and E, and you can get F in terms of A, which is what we want. We want we want output in terms of the input. That's what we're looking for. So right here, WE. So that is what you get when you make this substitution using this equation right here. Except that the arm is equal to WE here, right? And then through algebra, which I know you guys are going to, that'll be what you guys do. That'll be your problem. I could do it out in front of you, but I'd have to do a bunch of these. How much time we got? I'll just snip it. I'll snip it, the algebra, so you guys can see how it works. But I will... I'll name it Algebra 1. So Algebra 1 is this right here. So let me get real tight here. So this right here, remember, is where we left off, right? So this is the equation that I wrote right here. It starts here. You then obviously FOIL these out, right? And then you do some pulling out, right? You pull out a WE from the equation, and you get this. And then you obviously divide this over, and you end up with WE is equal to NA NC divided by NA NC plus NB ND, right? So like I said, it's just a little bit of algebra. You'll have to do some pulling out, some factoring, things like that. But this is what you get, right? From our original equation, you get this. And we get an equation, so this is what we were looking for. We get WE. And remember, WE is what we were looking for here. It is an equation for the arm, or in our case, WE. So that is good for us. We wanted that. And the reason why it is good for us is because of what? We know by, let me go up here, by our drawing, we know that by this drawing, gears E and F are contacting in a similar way that the other ones do, right? We know that they're contacting, which means that if we know WE in terms of the input, that means we can plug that into an equation where E is contacting with F, and we can get the output in terms of the input, right? Because that's what so like I said, that's what you ultimately want here, because think about it this way. You want to know if you put in X amount into here, what are you getting out over here? So if you do some odd velocity here, what is the velocity here, right? Would you guys agree? Because down here is what you're trying to spin. Like whatever the machine attached to it over here is, you want to know how fast it is being spun, right? It wouldn't make sense to go, all right, well, I know how fast A is moving, and then I know how fast E is moving, but I can't tell how fast F's moving, right? Just getting E in terms of A doesn't help us with how the output mechanism is. It doesn't help us. We need the F one as well. Jackson, you go ahead and have a question. I see you're typing over here. Or you're not typing. Accident. Okay. We almost had one, guys. So real quick, let me get real tight here. We have WE is equal to this, which means that if you look at this equation, what we have is we have gear teeth, gear teeth, gear teeth, gear teeth, gear teeth, gear teeth, input velocity. And like I said, if you know you're inputting a velocity, you know how fast it's going. And also if you bought all these gears and put them into your, into your machine, you know how many gear teeth there are, right? And if you don't know, just tell someone to go count it. Tell the intern to go count the gear teeth on the mechanism. So you have gear teeth here, and you have it at input velocity. So that means we've done a good job here. We have now E in terms of A and gear teeth only, which is good. That is what we needed to do. Now our next step is we need to write an equation for the contact of E and F, right? So it's the exact same. Essentially, it's the exact same. You do the same setup equation as you normally do, but there is a difference in direction. But it's not. It's just notation. How about that? It's more notation than the problem being correct or incorrect. But essentially, you do the exact same thing. You do WF times NF is equal to WE times NE, right? Same contact equation as before, right? And so we have gear teeth, this right here, which we have just found, right? You guys would agree we have just found it from that equation. And we have WF and NF. So we do the exact same thing we did before, which would be WF is equal to NE over NF, right, times all of this stuff, which I now have to put that in. So NA, or NC, NA, it doesn't really matter. I'm going to have to go ahead and increase that, I think. NA plus NC plus NB ND. Let's go ahead and figure this out. And then times WA. Right? So do you guys see what I've done? Essentially, I've just taken this equation for WE and I plugged it in right here. So you get NE over NF times what I just plugged in, which is effectively all of this. And you could obviously, you can maneuver this around and get it to look nicer, but essentially that is what it is. I just plugged in WE right here. And so, once again, now what do we have? We have the output velocity, which is this, in terms of gear teeth, 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 input velocity. So we now know how fast the output shaft is rotating, or the output gear is rotating, only in terms of what we know, right? This equation, we know everything in here, which means that we can find it. And there are actually questions. I don't know about on your homework, but there were questions in previous years where they gave you the gear teeth, and they gave you the input velocity, and they told you to find the output velocity. I took that out because of just time constraints. We don't have, I'm just trying to teach you guys really quickly, like, the basics of how to do the question. The numbers are pretty simple, though, right? Like, for example, if you knew this equation, let's say you got to this point, and I gave you that NE was 20, NF was 35. If I gave you all the numbers for each of these and the input velocity, that's a matter of just plugging into your calculator, right? There's no extra understanding that has to come in. It's just that if you just plug it into your calculator, you'll get an answer. So that's why I'm not really focused on that. I'm focused on if you guys can make this table and get these equations. The numbers, that's kind of trivial at that point. Alright, so let me go ahead and update where we were at. So we were here. So find an equation. We did find that. I forgot to do it when we did it. So this is what we did. We found an equation for WE and we plugged it into the equation for the output. So we have completed it right here. Congrats, guys. We did it. Right? So now there's one last step. And the last step is to find the kinematic coefficient for the gear in question. So the gear in question, I guess it got rid of it, but that's okay. So the gear in question. All right then. So for the gear in question. And so for this question, you know, let's just say I asked for the kinematic coefficient of gear E, right? We'll do both of them. We'll do gear E as an example, and then we will do gear C really fast. So gear E, the kinematic coefficient in this chapter is whatever is in front of the input velocity in the equation for velocity for whatever gear you're looking at. So for example, the kinematic coefficient for gear E is just this quantity right here. It's whatever is attached to our input velocity. It's just whatever's in front, whatever's behind it. So it is this. This is the kinematic coefficient for gear E. Does everybody understand that? Because this is asked on your homework. I don't want anyone to turn it in without or it'll be on your exam too. I don't want anyone to not understand where that kinematic coefficient is coming from. It's really easy. It's free points, guys. It comes just once you find the equation for the gear that I asked for. So let's say I asked for gear E, and you have this equation, and I go, what's the kinematic coefficient? All it is everything not including that. That's it. I hope you understand that, because if you don't, that's going to be sad. But really quick, we'll do another one just so we can nail this one down. We're going to do the kinematic coefficient of gear B, right? Because gear B and gear E are the same, or gear B and C are the same. So we'll do gear B. So kinematic coefficient of gear B. So what you do is you need to find an equation for gear B where it says WB is equal to this. So let's go ahead and do that. So we'll do that up here. So we have the equation right here. We have WB is equal to opposite of NA over NB times WAR plus WE. So we're going to maneuver this equation once again. So WB is equal to NA over NB times, and I'm going to go ahead and do the transformation. I'm going to take WAR and I'm going to sub it out, right, and put in WA minus WE in there, plus WE. All right? And that is just this equation right here, except I substituted WAR out using this right here, this relationship. Now we move on. WB is equal to the opposite of N over A, NB times WA plus NA over NB times WE plus WE, right? Let me see. Can you get this in terms of the input though? I wonder if I chose a bad example. So WA is here, NA, WE. I don't think you can get this in terms of the input, actually. You might not be able to. Let me look and see. I don't think they actually did this part, but you might not be able to get this in terms of its input. Because of this gear in the middle. W arm. So if that was W arm. Oh yeah, you can. I'm dumb. Oh my god. I'm psyching myself out. I'm not dumb. So if you didn't get it, you're not dumb either. It's just I psyched myself out of it. So I forgot we had an equation for WE. So WE is down here, so you would just plug in WE and you would have A right there. Yeah, I'm sorry, I've completely blanked out there. Is equal to NA. So this will be NA. I'll go ahead and do that though, just to not have people confused. Man, I can't believe that. Let me see. And this will be NA times WE plus WE. Actually, no, I'm not going to do that yet. I was going to do something else first, but I'm not going to do that yet. It seems like a bad idea. Alright, so I'm going to go ahead and plug this in. This is going to get messy because it's a long process, so I'll just do as much as I can. So, we are going to plug in WE for what it means, which is right here, which is NA times NC over NA NC plus NBND times WA. Right? So it's this, so what we had before, which was right here, it's just this times WE. So NA over NB times this is what WC is, or WE is equal to. Then it is plus the exact same thing, which is NA, NC, NA, NC, plus NB, ND, times WA. Okay, wow. That is quite a bit. And then what you have to do is you have to you have to get like terms from here. So what you would do is you would get I think you already have you'd have to get like terms. So what that means is essentially you would have to find a way to factor out what you can from all of these. And if you can factor a WA out of all of them, and do what you have left, that would be, it'd be so it'd be WB is equal to a bunch of these things times WA, and whatever is in front of WA is the kinematic coefficient. This is going to be quite a bit of algebra, and it's going to be hard to do on a screen without being able to write it down. I probably should have done this beforehand. But essentially, from here, guys, it's just algebra. It looks like complicated algebra. I will agree with you there. So what you would do is you would just have to multiply and get like common denominators, right? And once you got common denominators, then you would probably just be able to pull out WA, and whatever is left is what you would use as your kinematic coefficient. So let me put this in big bold letters here. The kinematic coefficient is what is in front of WA, or the input of the input velocity ND. Wow, big bold letters backfired on me here. Whatever is in front of the input velocity in the equation for the gear you are looking for. So if you're looking for the kinematic coefficient of, like I said, gear C or B in this case, it is whatever is in front of A. Now the problem is that you have to get everything like to get it in front of A. You can't just say, well, it's this, and it's this, right? You have to have WA times a bunch of things, and all of that is the kinematic coefficient. So it's algebra at that point, but that is what it is. Of course, that's how it worked. Never mind. So, are there any questions about this? Like I said, this example may pretty straightforward. I hope the one on your homework is. I think it is. And I'm going to remove. So don't do the second question. I'm going to remove the second question and put another one in there because the second question is a differential, and we don't have time for that, unfortunately. I might talk about it just a tiny bit tomorrow, but I don't expect you guys to know how to do it before turning it in on Sunday or Monday. If all of you are good, then I will go ahead and stop, and then we can take attendance really quick. All right, you have a couple seconds, and going once, going twice, sold.